So, welcome again, and this is the last presentation on this awesome event. And today I'm going to talk about attacking AWS. And the kill chain I'm going to present is a little bit interactive. And if you want to decide which steps should be taken, please follow this link. Slides should be changed automatically. Should be, because this is the first, this is my experiment with this presentation, so we'll see how it works with you. So, I'm working in a securing company, and I'm doing, on my daily basis, I'm doing penetration tests, and also cloud security assessment. And regarding this cloud security assessment, today I will share my experience. So, the link to the interactive part, you can see here, it is still the same on every question, so it is not changed. But my first question to you is, how comfortable do you feel in AWS? So we'll give you a little moment for making a decision on your smartphones or laptops. So let's see the results. Whoops, sorry. Here's the question. So yeah, make a decision, and yeah, let's see the results. Sorry. Yeah. So my impression is that a lot of security folks, well, while they are cool in any other security field, in cloud, there is a big gap. So let's see how it works for you. Now we can see we should see the results. So, yeah, most of you vote for. I use it from time to time, and basically that's the same impression I have. However, more and more companies are going into cloud, and we can see on the global market of cloud computing. So every year, more and more companies are putting their services into cloud. However, they don't realize about the security risks related with cloud. So the first example is from Tesla. So they put the Kubernetes console, and this console was publicly available without any authentication. This console was for managing their applications, which were hosted on cloud, but so for managing those applications, they had to give the proper permissions. Those permissions, so the AWS access keys were taken by the attackers, and they put the cryptocurrency miner for what it was paid by Tesla. So Tesla paid for this, and attackers get money. Another example is from Uber. So the attackers gained access to their private repository in GitHub, and they saw that in their code there are hard-coded AWS secrets. So using those AWS secrets, they were able to leak data about the Uber's customers. But it can be worse. And here's the example how such situation hypothetically may look like. So, manager want to sell everything, want to have as much money as possible. So, the customer asked about AWS expertise, but the developers didn't have it. So, the manager found a great idea to put their testing environment into cloud, so developers can learn AWS on the live organism. But in the other end of the internet, there's a hacker man who, in this presentation, will be you. So the application looks like this. So this is the application on the testing environment, and basically you are putting a domain name, and then in the output, like Google PL, and in the output, the application gives you all the threat artifacts related with the certain domain. This output, if you know the web page threatcrowd.org, this example is written in HackerOne. So I took it to show you what may go wrong. So if you put instead of domain name the IP address, you can see that it is reflected. So this is the first hint. And what is more, there are publicly available AWS IP ranges. So based on the IP address, you can know what AWS service is actually used by this IP address. And you can see that our domain analytics.online uses this range. So it's the region and the Elastic Cloud Computing Service. If you want to find, it's in JSON format, and the tool to EC2 reachability test. Here are the links. So what do we have? The hackerman just draw the picture. So we have the web application, which is publicly available. So the security group is like the firewall in AWS, in Azure also. And you have to explicitly define that this port will be open. So it is hosted in Elastic Cloud Computing. So now, question to you, what would you do? Find vulnerability in the web application, or rather find vulnerability in other services? Please vote. I will give you a moment. And let's see the results. Whoop. Yeah. Well, yeah, demos. So I can see, well, you can see on your smartphones the results. So most of you find vulnerability in the web application. So let's see. So which vulnerability you think that is more beneficial from the attacker perspective? Cross-site scripting, or rather server-side request forgery? Please vote, and let's see the results. So most of you, yeah, that's the correct answer. Most of you choose the server-side request forgery. Cross-site scripting is the client-side attack, so nothing fancy with attacking cloud infrastructure. So let's see. So we have here the web application. So we can change the address to the address 169.254, 169.254. What is special about this address? This is actually a link local address, which is actually accessible only from the Elastic Cloud Computing instance. So it's not routable, and it's the same for all Elastic Cloud Computing instances and other AWS services. Using it, you can refer to the identity and access management, which actually means that you can access the instance profile and get permissions. So using the vulnerabilities like server-side request forgery and XML external entity or remote code execution, you can find that there is a web server role. And when you go there, you will see the holy grail. So there are the AWS keys, which are generally used by the instance to allow them for some actions. That's cool. But what is actually metadata? Metadata is the information about the instance, so any internal information about the instance, like internal IP addresses, like host name, and its link local address, what means it is accessible only from the one, which works only in the one network segment. From the security perspective, the most valuable part is going into identity and access management, security credentials, and there is stored the AWS access keys. So let's sum up. Actually, if you choose other path, there is actually all ports are open. So security group is set to be publicly available, but using this, you can access the instance profile. So let's say the web application gives you the functionality of uploading files, then you have to give the EC2 permission to write objects to, for example, S3 bucket. Let's see, but we don't know what we are allowed to do with that. So here's the PACU, and the PACU is like the Metasploit for cloud. So it's very similar, and guys from Rhino Security Labs, they are inspired by Metasploit, and we will be using it a lot today. So let me show you how the PACU look like. It's written in Python 3. You can choose the name for each session. So what is cool, because if you are doing like me parallelly a few projects, then all the findings are separate from each other. So what do we have here? You can list all the modules by simply command ls. If you don't know what the module means, then use help. All the output from enumeration is accessible using data. So you can take the keys you found and import it to the PACU. So let's do it here. I will call our victim the EC2 pivot. Then you are just putting the access key ID, secret access key, and the security token, because instance profiles also use STS token, which is required which expires. So from time to time, you have to use it. Then you can set region, and we know that our application, our target, is based in European region. Here are just quickly what modules you can find. So a lot of modules for enumeration, for privilege escalation, for lateral movement, and to exploit. We will use a couple of them, so you will see them in action. All right. So how to enumerate permissions? In PACU, there's a module called Identity and Access Management Enum Permissions. And using it, you can display the permissions which you are allowed to do. But to be able to display all your permissions, you have to have assigned those two permissions for these two actions, which is actually, at least from my experience, it seems that it is very, there is a little possibility to find it in the instance profile. But, so here's another question. What we can do if we don't have any identity and access management permissions, what can we do? We found keys. What is the next step? There's a known exploit. Well, the sad thing is there is not any known exploit, and the only thing you can do is actually brute forcing permissions, which is super loud, but if the configuration is bad, then you can run the identity and access management brute force permissions and simply brute force all permissions. In PACU, only supported services is the elastic cloud computing and simple storage service. And if to enumerate permissions for other services, you can use just a simple script to try every action. And in fact, it seems that for our web server role, there is assigned a policy which allows for any action in elastic cloud computing. And this wildcard is super common. Developers prefer to put a wildcard because then it always works. So you don't have to, specify each action, just a wildcard, and it just works. It's a testing environment, right? So what's the risk? In PACU again, we are using the elastic cloud computing enum module, which is actually taking all the information using your keys about any other services, about the EC2 service. Then we can access it using data EC2. So what did we find? There's a stopped instance with the ID like this, but this time the stopped instance have assigned admin profile. And actually, this example is taken from one of our customers. So let's see on this great picture. So we found the web server role. There is stopped instance. We know that there is a stopped instance, but what can we do? Question to you. Yeah, please vote. What would you do in such scenario? Either you will run the EC2 instance completely new with the SSH keys, or you will update the user data of the stopped instance. Let's see. Update user data. Exactly. First of all, what is user data? It's the list of bash comments, which will be executed once the instance is started. But it will be run only once. But there's a special trick how to do that. This user data will be run every time the instance is restarted. So let's do it. Sorry. Not this one, but yeah. So in PACU, there's a module called EC2 Startup Shell Script, which will basically update user data for you. So what can we do? So let's see the help of this module. You are given a script. So what actions, what bash commands should be executed once the instance is restarted, and the instance ID, instance of our stopped ID. So here I'm verifying my external IP address, and knowing that, I created the ref shell, which is basically the bash one-liner, which gives me the reverse shell. Okay, so I'm starting the netcat listener, and I'm listening on lead port. Then I'm starting the module EC2 Startup Shell Script to update user data with the ref shell. And yeah, we got the output that instance is modified. So if we are lucky, this ref shell should be given to our hackerman. It takes a little. If you are familiar with starting EC2 instances, you know that it is not work. It doesn't work like very quickly, but you have to give it a time. And now, what is the trick? Okay, let's wait with this. So, a little pause. Yeah, as I said, it's starting quite. But yeah, we finally got the shell. So again, using the same trick, we can access the metadata, but this time gain the credentials of instance profile, which is called admin. So the trick I told you that it will allow for running the instance, running the user data every time you restart the machine is to add the directive cloud boot hook. Once you add it in the beginning of user data, it will be every time executed once you restart the machine. So let's summary. So using the web server role, which we gained using the server-side request forgery, we started EC2, stopped EC2, we changed the user data, which gave us the reverse shell, and finally, we got the admin permissions. Now, we got admin permissions, but that's not the end of the story. By default, the AWS CloudTrail service is responsible for logging all the actions. And by default, it monitors all AWS regions. And the logs is going into S3 bucket. So what the attacker can do, there is a special flag, which I will show you in a moment, that you can set the CloudTrail to observe only one region. So if the administrators work in only one region, they will don't see any changes. So the logs will be still given, but you can do whatever you want in absolutely every region, and it is not detected by the administrators. What else? You can remove the S3 bucket, but it is pretty loud. Or you can disable CloudTrail service, which is also quite loud. So again, with PACU, there's a module which is called detection enum services. So using the admin account, I'm running the detection enum services to get all the information about the CloudTrail settings and CloudWatch settings. In a moment, you can see that the PACU discovered that there is a one CloudTrail service set, and there is the CloudWatch alarm also found. So using the data CloudTrail, you can get the configuration. So include global service events. It is set to true, what means it monitors all the regions. So then we are running the module detection disruption, thanks to which you can not only disable or delete CloudTrail, but you can minimize. So set those flags to only monitor only one region. What is more, the service also discovered the billing alarm. So billing alarm is something that if you are, for example, used to get $5 for all your AWS usage, then if someone will run the cryptocurrency miner, you will quickly be notified that there is something bad. But you can simply, using the admin permissions, you can of course simply just remove it, and PACU allows for it. So after running the minimize, I again enumerate the monitoring services, and then you can see that include global service events flag is set to false, and the others also. So now, once we disabled all the monitoring services, it's time for persisting access. There are a few ways to do it, but in my opinion, the most interesting ones is the add extra keys to existing users. How does it look like? You are running the IAM backdoor users keys, and then another key pairs is assigned to each of the user. What is actually not a bug, but it is an Amazon feature. So you can use, it's a feature that you can use to separate key pairs under one account. And Amazon says that okay, it's cool because thanks to it, they don't share the keys. Well, I also want to show you how does it look like from the administrator perspective. If you are using services like GuardDuty, which are the intelligent threat detection service, it will tell you nothing, because creating additional keeper is nothing suspicious from the GuardDuty perspective. How does it look like from the administrator perspective? You can see that access key age is 5 days, right? And there is also assigned multi-factor authentication. However, multi-factor authentication is only assigned for the console, so using the web, but using the keepers, then MFA is not supported yet by Amazon. So you can see that the access key age, 5 days, is actually referring to the older keeper. So the administrator really have to do a big work to see that current user is using actually 2 keepers. So let's analyze what went wrong. First of all, there was for sure the publicly available vulnerable application, but there was also the test instance with admin permissions, no matter if it is stopped or not, missing monitoring services, and improperly configured services like CloudTrail or security groups. So I want to present you the methodic I'm using to make the complete cloud security assessment. It is not only verifying the configuration, but also, first of all, doing the architecture review to verify if there are no special extra resources. And yeah, from my experience, we found once the extra cryptocurrency miner that customer wasn't aware of. Then the configuration review, there is the AWS SIS Foundation benchmark. So it's a list of steps which you can basically, you can verify if your configuration is set up correctly. Finally, pen test sensitive services like the web applications or the serverless code. Serverless security is a huge topic which could be for the whole presentation. And finally, the cloud security assessment should also include the verifying monitoring processes. So is it, the sensitive actions, are the sensitive actions are really monitored? And if so, will you be notified if your, for example, employee is trying to do something malicious? So in practice, if we do the configuration review, for example, using Prowler, it will quickly detect that there are misconfigurations in CloudTrail service, because actually it should be, the bucket should be managed by other AWS accounts. So even if someone will escalate his privilege to administrator, he still cannot do anything wrong with the logs. Of course, the logs should be also signed and encrypted. Then, pentesting sensitive service, it would be pretty easy to detect this vulnerable web application. And if you remember at the beginning, the application, this example came from threatcrowd.org. You can find the report on HackerOne. But guess how the administrators of ThreatCrowd, how they blocked, how they fixed this vulnerability? Any ideas? Basically, they blacklisted the address 169.254, 169.254. So, any ideas how to bypass? We are used to use the decimal representation of the IP address, but always remember that the same address we can represent using the hexadecimal, using binary. So, so a guy who reported it then after reporting that this fix can be very easily bypassed, then they fix it correctly. Then monitoring sensitive processes would also notify, it should also be a finding from the cloud security assessment perspective. And then there shouldn't be any test instance with admin permissions. And really, trust me, it was running on the production application. So there were production application with the limited permissions, but there was one test instance which was stopped. So such kill chain was possible. And at the end, this is the Gartner report, and through 2022, at least 95% of cloud security failures will be the customer's fault. So Amazon will say, hey, we are doing a good job. The failure is, they will blame you. In the end, if you are interested in attacking AWS, here are a few extras. So CloudGoat is the platform which you are deploying under your AWS account, some vulnerable AWS services, and your goal is to exploit all those vulnerabilities. If you don't know how to start, I also created the 5 articles to how to work with it, how to find vulnerabilities. Of course, PACU, try it. I also created the Capture the Flag game, which is called Karka Analytica. And when you want to play, if you want to play, just see it. And there are vulnerabilities related with simple storage service. Also, to do the cloud security assessment, very helpful can be Cloud Mapper, which will display you all resources, and also if there are any possible paths to escalate your privileges. And the Prowler will do automatically, will detect automatically any misconfigurations in your AWS services. So that's all from my side. If you have any questions, I'm open. Yep.
Hello, thank you for the presentation. It was quite interesting. If we're talking about like full kill chain of the attacking AWS, I'm wondering how difficult or easy are actions on objective in terms of cloud environment. For example, if attacker would start to exfiltrate data or started using resources, is it easier or harder to detect for the owner of the instance compared to bare metal?
Well, it is harder because, for example, there is something like virtual private cloud, which generally makes you a private cloud and it should be separated. But there are features like, for example, even if you are using the VPC flow logs, it is still possible. The VPC flow logs are not monitoring any DNS records by default. And you can exfiltrate all the data using DNS, and there are not, and by default, if you don't change some things, you will be not notified. And regarding exfiltrating data, it is pretty difficult because normally you are using you are accessing some simple storage service, and from my experience, it seems that all the users can display all the content of the buckets. And if you treat it as a normal behavior, then you will not see any anomaly in this that some objects were accessed and then exfiltrated.
Thank you.
Anyone else? All right, thank you.
Okay, thank you very much. you.